Hello students, how are you all? Welcome back to the lecture number 6 of current and electricity. Okay, today we will visualize that what is resistance. But before that, let we have a pipe through which some water is flowing. Right now, think if some waste material is present inside that pipe, it blocking the flow of water. That means that impurities or that waste material is actually helping to decrease the flow of water. So the outcome of flow before is right now decreases in a smaller amount of flow. Okay, the same thing is happening in our conductor. We can say about our conductive wire through which some electrons are flowing right now. If some impurities are not present over there, then all the electron will flow from one end to another very easily. But if some impurities are present over there, then few of them will get a strike with this kind of impurities, and few of them will come out from one end to another. That is the concept of resistance or resistor. That is what actually a resistor do. Right now think about it. Whenever the flow of electrons is decreasing due to this kind of impurities, the current is also decreasing. As we know, current I equal to charge by time, that is totally depending upon the charge. Right now, from our Ohm's law, we know that V equal to IR. If the potential difference V is constant, then we can say R is inversely proportional to I. The resistance is inversely proportional to the current. That means, think again, if electron will decrease, current will decrease. If current will decrease, then resistance will increase. Now think reversely. If you increase the resistance, that means if you increase the impurities, that means the electron will decrease, so current will decrease. That is what this formula is denoting. Alright, so right now we will discuss that the dependency of resistance on some circumstances. First one, whenever I got a wire, conductive wire of length L, if you increase the length of that wire, the resistance is also will increase. Why? Suppose I got 1 meter of wire and say there are 2 impurities. If you increase it another 1 meter, that means right now in that wire there are 4 impurities. If you increase another one, that means the total right now is 3 meter. Then you got 6 numbers of impurities, and we know that impurities increases the resistance as it is block the flowing electrons. So if you increase the length, the resistance will also increase. That is the first dependency. Coming to the second one, if you increase the area of cross section, whenever you cutting one wire through a cross section, you will get a circular area, and that is I am taking as capital A. So if you increase the area of cross section, that means the impurities present over here are getting a space between them, through which the electrons can flow very easily. So right now the flow of electron is increasing. That means if area increases, current will increase, and we know if current will increase, that means the resistance is decreasing or resistance is less. So from here you can say the resistance is inversely proportional with the cross sectional area. Okay, so here the resultant relation, that is by combining these two, so R proportional to L by A. By taking a constant term rho, we can write that R equal to rho L by A. That is a constant term, which one can be expressed by resistivity. if you rearrange this one in the form of resistivity, you will get Ra divided by L. That is Ra divided by L. This is the formula of resistivity. So we just learned that rho equal to Ra by L, where rho is the resistivity. Right now we will check out its definition and SI unit. Okay, so before making that definition, let's learn how to make a definition. From this formula, if the area of that wire is 1 meter square and the length of that wire is 1 meter, then you can say that the resistivity is equal to the resistance, as you can see by placing the values. So from here we can define the resistivity by this, that for a conductive wire, if the cross-sectional area and the length is unity, that means you got unit cross-sectional area and unit length, then the resistance of that wire is known as resistivity. Clear? Now moving to its SI unit. Now coming to SI unit, you can say from this formula we know that resistance got the SI unit ohm. So I am placing ohm over here. With that, area, that is meter square, so into meter square, divided by length, that is only meter. So as you can see, 1 meter will cancel another and it will remain as ohm into meter. That is the unit of resistivity. Okay, now coming to conductivity. What is that? That is totally opposite of resistivity. Resistivity is actually block the electrons. It's actually decrease the current, while conductivity denotes the increase of current. That means how a wire is free to flow the electrons. That is denoted by conductivity. Conductivity is denoted by this symbol sigma, and sigma equal to 1 by rho. That means it is the reciprocal term of resistivity. Okay, now we will check the SI unit of that. So for SI unit, we know that 1 by resistivity and it's got the unit ohm meter. So the SI unit of sigma, that will be ohm meter, while you can write it as ohm meter whole to the power minus 1. So that's all for today. Thanks for watching and don't forget to like, share and subscribe. Stay tuned with us. Bye bye.